3, 2, 1. Yes! Good try!
That is not what was meant to happen. Hi everyone, my name is Eddie Robinson. After over 1 year of work and the second launch attempt of Summit, this thing finally got off the ground and actually showed us some pretty cool action. So Summit V1.0 is a thrust vector controlled rocket, which means that it has a gimbal in here that the motor goes in, that goes on both the X and Y axis, and is stabilised by using this flight computer just here. So as the rocket tilts, this gimbal here moves and tries to keep it upright and going on the right trajectory. This is the second launch of Summit V1.0. The first one didn't actually get off the ground due to a motor anomaly which created a fire on the launch pad. This launch was on an Estes F26 motor, which is about twice as powerful as it needs to be. If this thing flew straight, it would have theoretically got to about 101 meters above ground level, as the rocket's wet mass is just over 1 kilogram. The goal for this launch was to actually get into the air this time and get off the launch pad and fly as stable as possible, and then observe any errors to get the necessary data that I need to go back to the drawing board and recreate the guidance system for the next flight. Now obviously the first launch for this thing was quite stressful, the first time setting things up, hoping everything goes according to plan, and obviously it didn't with the fire on the pad. This time I was thinking, oh okay, it'll be less stressful this time, I know what I'm doing. No, I get to the launch site and it starts spitting just minor, small bits of rain, which wasn't too bad, but it's enough that it could do some damage and was a threat of heavier rain. So I had all my equipment set up everywhere and it starts raining. So I get the tarps out, start throwing tarps and towels over everything to try to keep things dry, and I sit in the back of the car and I start installing the ejection charge into this rocket. Eventually the rain cleared and there was a bit of a gap in it, so I was able to go out and try to actually launch the rocket. On the third ignition attempt, because the wireless system had some issues, the motor finally ignited and we had liftoff. The launch pad worked beautifully, all the clamps released, though unfortunately there was a pressure drop in the pneumatic system, so the strong back didn't fall back properly. The wireless system performed well, everything went, and the rocket finally went into the air, which is where things started to go really wrong. So this rocket uses what they call a state machine, which means that the flight computer here goes through different modes depending on what the rocket's doing. So when the rocket's on the launch pad, it's in pad idle mode, where you'll see a red LED on this flight computer and there won't be any thrust vector control, there'll be no stabilisation or anything, it's just sitting there waiting for the initial acceleration spike to go into the next mode called powered flight mode, where the rocket then begins to stabilise. There's other modes after that, but for this flight they're kind of irrelevant. I'll show you a bit of an example of this, just so you know what I'm talking about. So the flight computer here, if we turn on with the switch here, you'll see we have a red LED. So that's in pad idle mode. As soon as this thing detects an acceleration spike, it'll go green and it'll begin the thrust vector control stabilisation. There we go. So now if there was a gimbal connected to this, as we move this around it would be stabilising. Now I've tested these mode changes at least 100 times before this launch. However, every single time I tested this, I'd turn on the flight computer, I'd give it a jolt, and I'd tested it immediately. But there was a big problem on board that occurred after about 3 minutes of the rocket sitting on the launch pad. Basically, when this sits for 3 minutes, the memory on board gets filled up with heaps of data, and the computer basically crashes, meaning that no matter how many times you throw this around, it will not change into powered flight mode because it's no longer trying to detect a mode change. Essentially what I'm getting to here is that when this rocket launched after sitting on the pad for a little while, there was no stabilisation. This was literally just an uncontrolled flying tube with a very slightly offset motor mount which just flew across the sky and crashed into the grass. This is a very disappointing first launch. I'd expected the guidance system to actually work, as I didn't find this error until after the launch. I was hoping that the guidance system would at least do something, so that I'll be able to get that data that I need to continue moving forward with development. But no, all this launch is one step backwards. Now the damage from this was clearly the nose cone. Just here I have the top of it. The nose cone is in about 10 different pieces. So When the rocket flew, you saw in the video there, the rocket landed nose cone first, and the nose cone was actually fine at the time. It just got crushed into the rocket, and it got recessed inside of here. So basically what had happened is the bulkhead on the bottom of the nose cone, which the eye bolt goes into to hold the parachute lines, had just completely shattered, and the nose cone had been stuck inside of there. The reason this is in so many pieces is because I had to smash it to actually get it out, and in the process I did some minor damage to the carbon fibre work, with a little tiny crack in it. It's all fine. I'm working to make another nose cone, so I'll have to use a laser cutter again to make a new bulkhead, and another 15-hour print. If you want to know how I make these nose cones, I do have a video on this channel called How I Made the Ultimate Smooth 3D Printed Nose Cone or something like that. You'll see it if you go to my channel. Now, how am I going to fix this error, you're probably thinking? This is a pretty major software error. Now, the cause was simply my stupidity. I was rushing a lot to get this flight software done, and I tested it at least 100 times as I said, so I thought it would be fine. But it was irresponsible of me to rush software that goes into a guided rocket. That's just stupid. I'd taken my time with everything else in the project, but I rushed such a crucial part of this because I really just wanted to see some action. What I'm getting to here is that the way I'd be changing states on the flight computer is by doing something called recurring function calling, I think they call it. So basically, you've got the main loop in the Arduino code. That loop references a function, but then to loop that function over and over, I'm simply calling the same function at the end of it, as I'll show you on screen right now. What that means is that essentially it takes up a lot of RAM every single time I try to call that function. So when you're calling that function over and over and over and over, you're just really hanging that RAM, and after a few minutes, it's going to crash the computer. The computer's going to try to use more memory than what's available to it. And that's exactly what happened here. So the solution to this is to rewrite all of my flight computer code to be less sketchy, because right now it's very dodgy, and I'm kind of nervous to launch this thing again, considering it started heading straight towards the car park where there was cars driving. So I would be doing a lot of research into state machines. I'll probably be using enums to make a solution for this, and make a much nicer way of changing between states, rather than using this recurring function calling. As well as this, I'm making a motor adapter, as the next motor that I'll be using is an Aerotech F30, I believe, which is 24mm, and it's a 25mm motor mount. Now, I have already tried to make this motor adapter. However, I did this CAD really late at night, and instead of making the inner diameter 25mm so that the motor could slide in nicely, no, I made it 23mm. So the 24mm motor does not fit in this, and I need to redo the entire 4-hour print. These things happen, what can I say? Now, I do have an entire failure analysis report for this launch, which I'll link in the description. It's on my very dodgy website, which eventually I really hope I'll be able to do some upgrades to. But that report, I think it's about 3 pages. It goes really in-depth into what happened. So if you like all the whole technical report side of things and learning that way, then I think that report's definitely something you should have a read of. I am aiming to launch in 2 to 3 weeks from now. The reason this is going to take so long is because I have to rewrite every single line of flight code and then do extensive testing. The nose cone itself won't take long to fix. That's a 15-hour print and then a little bit of elbow grease after that. I do need to launch this by the end of this month. So I've already mentioned previously fireban season in Australia, where we can't light fires, and launching a rocket would be underneath that fireban season. So I need to try to get this thing launching by the end of November, as that's when fireban season starts. After that, I think it's about a 4-month period, 4 or 5 months, where I can't launch this rocket. So during that, I'll be able to do some pretty major upgrades to things like the electronics, and I'll be able to fix the guidance software and any bugs that I find next launch. Next launch's goal is to still try and fly as stable as possible to get that data that I mentioned earlier. Hopefully this time we actually do get into powered flight mode and see how the system reacts. I'll confirm the details of this next launch, and I'll keep you all posted with updates through Twitter and Instagram. So if you really are interested in what I'm doing and want to see more of that, then definitely go follow me on those social media pages. That's all I've got for you today. My name's Eddie Robinson, this is Robertson Aerospace. Thanks heaps for watching.
I don't actually know if the rocket even tried to stabilise.